Hi, I'm Sam Roberts from Roberts Geospatial Engineering. Today I want to show you how to create bathymetry grids from LiDAR data. We're going to be using MapInfo Pro Advanced and we're going to be using Pro Raster. So don't forget that you can visit my website at robertsgeospatial.com.au. The address is on the screen, and there you'll find software and articles and data and services that can help you with your geospatial data processing and analysis and visualization. So let's get started. So I live on the Central Coast um, in New South Wales in Australia, which is just north of Sydney. And I was aware that LiDAR had been flown in this area, and so I went looking for the data. Geoscience Australia at some point have put together a raster compilation of all of the surveys that have been flown up and down the New South Wales coast. And you can see it here. So we're looking at Pro Raster, and we have a 5 meter resolution raster. So if I zoom in to the Central Coast north of Sydney, here you can see the data, and here's my house here at Copacabana. So there are some major problems with this data. For starters, you can see that they've triangulated out into the ocean. So here's the beach, and out into the bay. They've triangulated out into here. Here is Brisbane Water. It's an inland waterway, and it's filled with triangulation. I wasn't happy with that. Also, in some areas you can see processing artifacts. So if you take a look here, you'll see this crisscross pattern, which is has been introduced by some kind of processing problem. I think this data is seriously flawed, and I wasn't very happy with it, so I went looking for the original LiDAR data. Let's download some LiDAR data. I've gone to the Elvis website, which is elevation.fsdf.org.au, and this is a server that you can acquire elevation data for Australia. So hit the order data button, and I've put in a manual search rectangle, so let's just search for that small area which is over the Central Coast, and you get some results. So you can see here that you have digital elevation models, and you also have point clouds. So the point clouds are what we're after. But you can see that there are two different sets. There are point clouds from New South Wales Government Spatial Services, and then there are point clouds from the New South Wales Government DPIE. So the spatial services are the ones that you want. They are the collection of LiDAR surveys that have been conducted by various LGAs and councils and so forth. And this one that's on the DPIE server, it turns out to be a completely different thing. So this was a survey conducted in 2018 of the entire New South Wales coastline, and the survey was designed to measure bathymetry of the near shore out to about 200 meters, and not the terrain. So we're going to have a look at some of that data as well. So you select the data that you want, and they send you an email, and you download it. So let's create a ground surface from some LiDAR data. I've opened MapInfo Pro version 2021, and I have MapInfo Pro Advanced installed, which is the raster toolkit. So if we go to the raster tab, there's a LiDAR tools option, and in here you select surface, and it comes up with this dialog. So firstly you need to load your LAS files. So I'll just add a few LAS files. Just grab a few. Got 10 files there. Hit OK. Now I'm going to select ground as the surface I want generated. Just change the file name and hit process. And in a short while we'll see a raster displayed in a map. So it's going to be using triangulation, and there are no limits to what this particular algorithm can achieve. So you can bring in LAS files or LAS files, an unlimited number. You can bring in an unlimited number of points, and you can generate arbitrarily large rasters. There is no limit on what you can do. However, I would caution you that if you intend to grid 100 billion LiDAR returns, which you can do. You might not want to do it on a laptop like this. You might want to get a more dedicated data processing machine, because you're talking about doing a lot of hard work. But here you can see it's generated a raster. This is the ground surface. So things like buildings are not included, and trees are not included. You can see that there's some holes in the raster. So it has to triangulate across gaps, and gaps are caused by building footprints, by trees and so forth. And you can control that. If you have a look in here, there's a maximum triangle size, and it's set to 25 meters by default, and we've got a 1 meter cell size for our raster by default. If I increase that to say 50 meters, then a lot of these gaps will get filled in. However, by increasing that triangle size, you then will start to get long triangles generated on the edge of the raster, for example, along the coastlines, where you might not want them. So then there are some other clipping options, and I won't describe these, but you can use polygonal clipping or this near and far clipping option to start to control some of that additional interpolation into areas where there's no data, where you don't want any raster cells generated. So that's our terrain raster. Now I want to generate a bathymetry surface from LiDAR data. So we'll start again with MapInfo Pro, and this time I'm using the 2018 survey data. So instead of going to LiDAR tools, I'm going to have to do this one by hand. So I go to Create Raster and I choose Triangulation. Once again, go in and select my files. So I'll add some files here. We need this one, LAS. I need to select the LAS filter, and we'll just grab some of these files. It will automatically select the Z column for you. That's all good. Now, in order to generate a bathymetry raster, we need to select the correct returns from the LiDAR data. So this is called LiDAR filtering, and I'll press this button here. We'll select by classification and then by return. Now, in this particular survey, some standard classification numbers have been overridden and used for bathymetry, so we need to go in and select them. So the first one is ground. We want the ground surface. And then in this data set, I happen to know that I think it's 13, 15, 16, and 17 are all bathymetry returns. So they're not wires or transmission towers, they're actually bathymetry in this case. And then instead of selecting all returns, we just want the last return, which represents the, if you like, the furthest from the instrument. So hit OK. We're going to use triangulation. Now I'll just change this so that we get maximum triangle size of, say, 50, which is what we were going to use before. Cell size, we'll put in 1 meter cell size. Oops. And I'll just change the file name again, so test3, and then hit process. So I haven't changed many options there. The main thing is that you have to establish your filter. So this has created a raster again. And now actually you can see we're just lucky that we've got some terrain, but then we've also got some offshore bathymetry in this bay, and I can tell you that that looks like Pearl Beach. So that's how to create exactly the same kind of raster, but doing it in a more manual sense. So that the LiDAR tools, let me take you back to that. So these LiDAR tools, this surface tool, this uses exactly the same gridding methods as the Create Raster tool. So it's all using the same triangulation code. It's just that this one has been greatly simplified for users, and there's not so many options. But at the end of the day, it all runs through the same code, so you'll be getting the same kind of results. So I want to show you Pro Raster now. Pro Raster is new software that I'm currently developing, and soon it will be available for you to purchase. It will be inexpensive, and you'll buy it via the Microsoft Store. It works with MapInfo Pro, and what it does is it creates an algorithm. An algorithm is used to render rasters in various ways, in ways that are far more flexible and powerful than you can currently do through MapInfo Pro or through other GIS software for that matter. Once you've created the algorithm, you can then load it into MapInfo Pro. And the algorithm itself is just a XML file. It's just a description of what MapInfo Pro should do, and it knows how to render those algorithms. So let's create an algorithm for the LiDAR terrain data that we've generated. So the easiest way to do that is to get ProRaster to make one for you, a default algorithm. So I'll go New Algorithm for Raster, choose my raster, and here you can see we have a result. So we have a pseudo color visualization of this terrain data. It's doing hill shading for us, and that's all great. So I just want to make some small changes. I want to use a color table that ensures that whatever terrain raster I'm looking at, I'm getting the same colors for the same data values or for the same elevation values. And I've set one up, so I'll go and select it. It's called Atlas Intertidal. So you can see that it's got blues here for data that is below sea level, and then Atlas style coloring for data that's above sea level. So select that. In order to map data to color, you have to provide a transform. The transform is actually inside this color table, which means I need to select that color table as the transform. So I'll do that there. And there's a result. So this is our terrain data for the Central Coast, and coloured nicely. We're not seeing any bathymetry data in here. There's a little bit of blue, but there's no bathymetry in this particular raster. So I just want to do some data comparison now. And I've loaded two algorithms into ProRaster. So the first one is the 5-meter terrain raster that I downloaded from Geoscience Australia. And the second one is the 1-meter resolution terrain raster that I generated from the original LiDAR data. So what I'm going to do is I'm going to close this preview window, and then I'm going to open an external floating window. So it opens up in a separate window, and I'll just put that on the left there. Now go to the other algorithm and do the same thing. Bring that over here. So now I have two maps on the screen at the same time, and I can do some comparisons. So let's zoom in to the Central Coast. I guess we're looking at about the same thing there. So you can see already a massive difference in quality. We've cleaned up all of this garbage that's out in the lakes and waterways and in the ocean. And what I was particularly interested in seeing is whether this problem, where we have this nasty interpolation artifacts, whether that exists in the original data. And if we zoom into the same area, you can see that it certainly doesn't. So here we have much higher resolution data. You can see all the building footprints. Of course, the buildings are not there. We've only gridded the ground returns, but no sign of any of these processing artifacts. Much cleaner coastline. In other words, a much more useful grid. I think it's the kind of grid that you can use for data analysis, whereas this data, I can't imagine that, that it can be very useful for data analysis at all. So I just have a second comparison here, and now we're looking at the 2018 bathymetry LiDAR survey. So on the left-hand side, I have a raster which I downloaded from the government website. So I'll just zoom in a bit. So it's a 5-meter resolution, and once again, when you start to get in close, you can see processing artifacts. So we have these vertical lines, horizontal lines going through the entire data set. Some kind of processing error has occurred in the generation of that raster. Now, on the right-hand side, This is the raster that I generated in MapInfo Pro from the original LiDAR survey. So if I sort of go into the same area, you can see that firstly we've got 1 meter resolution rather than 5 meter resolution, so more detailed. And then looking in here, for example, we don't have these processing artifacts that you see in the government supplied grid. Everything's nice and clean. So once again, quite disappointing to see that that the standard product that you can download from the government website is flawed, and the processing that has been applied to that data is flawed. But again, if you go back to the original data, and if you have MapInfo Pro, it is quite easy to generate a much superior product. Just wanted to do a third quick comparison here, and that's between the 1 meter terrain LiDAR from 2008 and the 1 meter terrain bathymetry and terrain LiDAR from 2018. So let's just zoom in to the same area. Perhaps zoom in a bit more. So, and come out towards the beach. So you can see that there's quite a significant difference in quality between the 2008 survey and the 2018 survey. If you look at the beach, it's full of noise, whereas in this survey it's nice and clean. Same up here in the hills. There's nice smooth results here in 2018, whereas the 2008 data quite noisy. So I'm not sure if that reflects better instrumentation or better surveying technique, but certainly interesting that there's been such a substantial improvement over those 10 years. So finally, let's just use Pro Raster to take a look at some of this bathymetry data. You can see on screen there's a little tooltip that I'm bringing up, which is telling us the elevation wherever the mouse pointer is. So out here you can see we get down to about minus 30 meters RL. So that's about the depth of penetration of the LiDAR system. I think it depends on water clarity. So out here in the open ocean, we've got great penetration. But if we then come down into pit water, you can see that we haven't achieved penetration in pit water, and it's probably about water clarity. The good thing about 2018 was that it was a drought period in Australia, and probably coastal waters were fairly clear, and so they got good results all up and down the New South Wales coastline, in my view. So if we come in here, for example, this is near Woy Woy. This is where the ferry tries to poke its way out to go down to pit water, and you can see that it has to run the gauntlet of all these sandbars, and that's why they've been complaining to council for the last 20 years to get them to dredge it. and on the Central Coast, we have hilly terrain, and you can see that the terrain doesn't stop at the seashore. It extends out into the ocean. And indeed, if they'd managed to survey a bit further out here, there would be a nice hill sitting out here in the ocean, because I know that there's a bombora out there, which is a rock platform that gets exposed at low tide. But you can see the quite complicated bathymetry in this area. And if you go for a walk along here, as I've done many times, you come to this beach, you see these sort of cliffs in the bathymetry create really dangerous wave patterns in this particular area. You'll see interfering wave patterns going at crisscross directions to each other. It's like getting into a washing machine if you try and go snorkeling off of this beach. Coming around a little bit, we come to Maitland Bay. This is a spot where I tend to go snorkeling quite a lot, and sitting right in here is the wreck of the Maitland. And you can see again this funnel effect that is going to be depending on the direction of waves, it's going to be funneling energy into the bay. And the Maitland sank here, was wrecked on the rocks. I think it was in the 19th century with loss of significant lives on one of those nights when waves were really being funneled into the bay and dangerous to shipping. Going around further north, you can see here's where I live. This is Copacabana, nice sandy bay, rock platforms all the way around, and you can see that offshore it's all hard rock rather than a sandy bottom. And over here, I've just noticed this. I must regrid this data and include the returns from shipwrecks, because that is a shipwreck. Not actually a wreck, it was deliberately sunk. It's a military vessel that was sunk out there, and it's an artificial reef that you can go diving on. This is Terrigal, another very popular snorkeling spot. You can jump off of the boat ramp here and snorkel your way around. And there's some sea caves and interesting features around here, and lots of grey nurse sharks, which are not dangerous unless you're a fish, in which case they're pretty nasty. Further north, lots and lots of terrain in the bathymetry. So really interesting data. I think it's fascinating. Um, I don't know much about the use of LiDAR for bathymetry, but obviously in the right conditions it can be quite successful and you can get really valuable data. So that's it for this video. I hope you found it interesting, and don't forget to go to my website robertsgeospatial.com.au for more videos and articles that may interest you.